Hello everyone, my name is Jakub Staroń. This is the next episode of MedChem Essentials, scientific seminars devoted to medicinal chemistry. Today we continue talking about solubility. And the focus of today's presentation will be simulated body fluids. Presentation will begin with different solubilities of drugs, then biorelevant dissolution media, composition of fasted and fed state simulated media, and in vivo in vitro correlation. During the previous presentation, we described how human gastrointestinal tract is constructed and how both fed and fasted state differ in their physicochemical properties. These different physicochemical properties will affect the solubility of different drugs. In addition, the short transit time through the small intestine may lead to incomplete dissolution and poor absorption of poorly soluble drugs. Let's see some data. Here on the right, we see a table with the actual solubility of a collection of drugs in the human intestinal fluids. Starting with griseofulvin, it's a neutral molecule and exhibits the same solubility in both fasted and fed state. Nifedipine is also a neutral molecule. It exhibits comparable solubility in both fasted and fed state. Dipiridamole is a weakly basic molecule and already has 8-fold higher solubility in the fed state as compared to fasted state. Diazepam is also a weakly basic molecule and shows slightly higher solubility in the fed state as compared to the fasted one. Cyclosporine is a neutral molecule and shows the same solubility in both fed and fasted state. Indomethacin is the only weakly acidic molecule in our collection, and as you can see, it's reversed, so it shows higher solubility in the fasted state compared to the fed one. And ketoconazole is also a weakly basic molecule and shows remarkably higher solubility in the fed state as compared to the fasted one. Both the gastric fluid and intestinal fluids and duodenum and jejunum, they differ in their pH, where in gastric fluids we see a median of 2.5. In duodenum we see pH around 6, between 5 and 6 median, and jejunum it gets already more neutral or basic through the infusion of the bicarbonates in the duodenum. What's markedly different here is also the concentration of bile salts and phospholipids. The infusion takes place in duodenum. So after in duodenum and jejunum, our more lipophilic drugs can have this support in being solubilized with the introduction of bile salts and phospholipids. So to have a good estimation and prediction of the solubility in human intestinal fluids, we need to develop sort of artificial simulated intestinal fluids, because it's quite completely impractical to have this screened and assayed in the actual fluids taken from the human body. So in practice, we have fasted state intestinal fluid version 1, version 2, fed state intestinal fluid version 1, version 2, and Copenhagen fasted or fed state fluids. They differ in the pH, FASIF 1 and 2, 6.5, FASIF more acidic, 5 and 5.8, and Copenhagen is the same, 6.5. The difference is visible also in the concentration and ratio between concentrations of bile salts and phospholipids, with FASIF version 2 having higher ratio. In FASIF we have similar ratio but higher concentration of both bile salts and phospholipids, and in Copenhagen the ratio is similar and kind of here the concentration is comparable to the FASIF and FASIF, but here we have introduction of monoleic and oleic acid. Which one of these fluids will be better, will have the higher predictability power for prediction of the solubility of our drugs? Let's see on the following slides. So we have our collection of molecules that was tested in the simulated fluids. The grisolfulvin, which is a neutral molecule, it exhibits solubility in human intestinal fluids of 60 micrograms per milliliter, and in FESIF shows underestimation of the actual solubility. Nifedipine is also a neutral molecule, and in FASIF will show underestimation as compared to the fasted state, 130, and FESIF, solubility in FESIF, both version 1 and version 2, will show slight overestimation of the actual solubility. Dipyridamole is a weakly basic molecule. In FASIF, we show slight underestimation of the actual solubility, whereas in FESIF, we show overestimation. But only through the modification of this FESIF fluid by introduction of the ox bile and citrates as a buffer, we'll see perfect accordance with the solubility in the actual physiological fluid. Let's move to diazepam. It's a weakly basic. Here again, despite of the type of the simulated fluid, whether it is FASIF or FESIF, we see underestimation. And cyclosporin is a neutral molecule, more than twofold underestimation. Indomethacin, again, underestimation, despite its FASIF or FESIF. This is the only weakly acidic molecule here. And for the FESIF version 2, we'll see accordance. Ketoconazole, a weakly basic molecule. Here is underestimation for FASIF. If we add to this FASIF, again, ox biles and citrates as a buffer, we'll see accordance to the solubility in the fasted state. And underestimation in the FESIF or FASIF as compared to the actual solubilities in the physiological fluids. Let's move to danazole. This is a neutral molecule. Again, underestimation, but only in FESIF version 2 we see some accordance with the fed state solubility. And finally, felodipine, again, twofold underestimation as compared to the actual solubility. This is a neutral molecule. So, which fluid will be the best one for screening and predicting of the solubility? As you can see in this table, we have very little accordance between the solubility in the simulated fluid and the solubility in the actual physiological fluid. Some accordance was obtained through the introduction, through the modification of these fluids, the introduction of these ox biles or citrates as a buffer. So, which one is the best? There's no clear answer to this. And the answer depends what is the purpose of the assay. If we want to compare compounds for their solubility, and we are optimizing the solubility of a range of molecules, then like in practice, any selection, we can screen solubilities in different fluids and pick one that shows the highest representation and correlation between different molecules, and then because we will be comparing solubilities of different molecules, and that will already give us information that will support our MedChem project. But if we are optimizing the molecule in terms of the formulation studies and solubility through the absorption, then we will need to design individual, unique fluid that will be applicable for the given compound, like you saw in certain cases was obtained through the introduction of this ox bile and citrates. So thank you very much for your attention, and see you next time. Bye bye.